Analysis of an irregular shaped drift on irregular subsoil. An example of an irregular shaped drift on irregular subsoil is selected to illustrate some of the essential features of ELPLA for analyzing raft. In this example, we have different grid intervals as shown in this figure. Raft material is Young's modulus 2 pi 10 power 7 kilonewton per meter square. Poisson ratio is 0.25. Unit weight of raft material will be 0 to neglect the effect of the own weight. For raft thickness it will be 0.5 meter. For boring logs we have 3 different models here as shown in this figure. Each log has uh, each log has 3 layers of soil, silt, fine sand and gravel. Each layer has its uh, level or depth or thickness from the ground surface as shown in this figure. For the groundwater table it will be 1.5 meter from the ground surface, and for the foundation depth it will be 2.7 meter. For boring location it will be as shown in this figure. And for load, Raft carries many types of external loads: concentrated load, uniform load, line load, moment in X and Y direction as shown in this figure. For more information or details about load dimensions, boring log, you can find it in ELPLA tutorial manual. It's required to analyze the raft according to the following soil models and numerical calculation method: layered soil medium, continuum model, modulus of compressibility method for an elastic raft on layered soil medium, solving system of linear equations by iteration method. 6. In the analysis, the following item will be taken into account: the effect of reloading of the soil due to the overburden pressure, the effect of water pressure on the raft, the irregularity of subsoil under the raft using the interpolation method. This tutorial manual will not present the theoretical background of modeling the problem. For more information concerning the method of analysis, a complete reference for the soil models and numerical calculation method will be documented in the user's guide of ELPLA. After opening ELPLA program, we will start from File menu here and select New Project. From Calculation Method Wizard, we will select Analysis Type. It will be analysis of a slab foundation. Then Next. We will select Modulus of Compressibility, Iteration Method, and the subsoil will be Layered Soil Model. Then Next. We will select System of Symmetry, Unsymmetrical System here. Then Next. And we don't need to select any of these options, so we will save the project to the destination folder. Maybe you can save it as example and save it. For project identification, we can enter 3 lines of text to describe the problem and the basic information about the task. These texts are required only for printing and plotting the data and result. Project identification doesn't play any rules in the analysis. We will select project identification and we can write here analysis of irregular raft. and maybe project example and save it. Then we will select FENet data. Here in FENet generation, you will select slab type. It will be rectangular with length of 15.01 and width 13.98. Then next, for generation type, we will select the first option here. Then next, for grid interval, we will enter it manually. So we will unselect constant grid interval and select grid interval here. We can select new, and we can paste it from Excel file if we have it, or enter it manually. We will enter it manually here, 0.9. We can copy it for 4 times, then 0.87. We will copy it for 3 times, then 1.08 and copy it for 4 times, then 1.12 and copy it for 4 times. Then okay, for y direction we will do the same thing. Unselect constant grid and select grid interval, new, and enter value. It will be 0.93 and copy it for 3 times, then 0.7, copy it again, then 0.93 and copy it for 3 times, then 1 and copy it 7 times. Then okay and finished. Then to select the unnecessary nodes which are required to be removed from the net, first to select node here from FENet data tab, then select the nodes we don't need it or we need to remove it. After select unnecessary node, we will select remove nodes from here and remove it. Then save FENet data and close it. Then we will select foundation properties from here, and to enter foundation properties we will select element groups here, and only we have to change slab thickness from 1 to 0.5. Then okay, for unit weight it will be 0 to neglect the effect of the foundation or own weight of foundation. Then for foundation depth it will be 2.7 from the ground surface. Okay, and after finish enter foundation properties, we will select save to back to data, then close it. After that we will select soil properties. We here have 3 pouring log. To enter soil data we will select soil data from here and enter layers. The first layer it will be silt with modulus of elasticity it will be 9500, and for modulus of compressibility it will be 26,000, and unit weight it will be 90, phi will be 5, and theta will be 30 for all layers, and layer depth it will be 1.5. Pouring log location in x direction it will be 4 and 3 in y direction for the first pouring log. Then we will copy the first layer here and select copy layer and go to the second layer 2 of 2. We here will change only gamma, it will be 9 because we use gamma submerged after the under the ground water table, and the depth will be 3.8. Then we will copy this layer again and we will change soil type from silt to fine sand. Select fine sand here. For modulus of elasticity it will be 22,000, and for modulus of compressibility it will be 52, and thickness or depth will be 10. Then copy this layer again. For the last layer it will be gravel with modulus of elasticity 120 and modulus of compressibility 220 and depth 20. So here we have the first pouring log. So we can copy this pouring log. Here we have the second pouring log. We will change the label to B2 and x coordinate will be 1, 9 coordinate will be 9 meter, and we will change depth here. Second depth will be 8.2 and third will be 14.1. Then we will copy this pouring log again. Third one it will be B3 and x coordinate will be 10, y coordinate will be 11, and depth will be 12.7, then 18.2, and after that we will select OK. ELPLA will draw the first pouring log. To draw other pouring log we will select list of pouring and select add all to add all pouring log for drawing, and here we have added all pouring log, then OK, and ELPLA will draw the 3 pouring log together. Then we will select main data to change groundwater table to 1.5, then OK, save pouring log and close it. After that we will go to pouring field. Here ELPLA will automatically generate or use interpolation method here for generation soil under the foundation as shown in this figure. We don't need to change anything here, so we will save it and close. To enter loads, here we will select loads and we can enter loads in table here. We will select point loads, and to copy loads data from Excel file, we will select a new, then we will go to Excel file here and copy point load, copy it, and then back to ELPLA and select paste from Excel, then OK. Here we have the point load, and we will do that again for moment in X direction, new, don't need that. Moment in X direction, we'll copy it back to ELPLA and select paste from Excel, then OK. For moment in Y direction, again, new, and go to Excel file, copy it, back to ELPLA, paste from Excel, OK. For line load, again, copy, back to ELPLA and select paste from Excel. We will delete the first line here, it's empty, and OK. Here we have. Finally, for distributed load, we will select rectangular type and select new again and copy load data from Excel file and back to ELPLA and select paste from Excel, then OK. Here we have loads, so we will save it and close. Here we have finished enter data for this problem. We will go to solver to solve this problem, and here we will select computation of all, and for accuracy we don't need to change it, so we will select OK. Finally, we will have this summary, so we will select OK and go to result. From result we can display or plot data and results from here or from this icons or items. For example, data in plane, we can plot slab thickness, element group, net numbering, coordinates, system of loading, column type. For example, we will select system of loading here. Here we have it. We can also plot it in isometric view as shown in this figure, and for result we can plot it in as a contour line. For example, we will select settlement. We have also contact pressure, moments in x and y direction, modulus of subgrade direction. For settlement it will be as shown in this figure, and for modulus of subgrade direction it will be as shown. We can also plot isometric view We can undisplay value from setting and select display value and unselect all. Okay, here back to result. We can also display result value, distribution curve, circular diagram, and formation as shown. We can also plot pouring log. Here we have three pouring log. Can select display value from setting here. Here we have the pouring log. We can also plot sections. For example, section in X direction. And select X direction. Settlement. Okay. And we can select section at Y coordinate. We can change it. Maybe select 5. Here we have the section. And okay. Here we have section of settlement. We can also display section for maximum and minimum value in X direction for settlement. Okay, and overlapping in X direction. We can do that for Y direction and arbitrary section. Here is it. We can also display tables of data and result. For example, display table of data, and we can select include. Okay, here we have table of data. We can export it or send it to Word file to print it. Thanks.